So, it used to be when I hear things like interstellar object is racing through space, fly by me. I didn't care. It is what it is. It in one ear, out the other. I really wasn't. Now. Oh man. If I hear something's racing through our solar system or through space, I'm literally about to drop my phone trying to get to it so fast to figure out what's going on, bro. Y'all have literally changed me, man. For real, bro. Y'all have literally changed me, bro. Like, I can't get to my phone fast enough. I'm fumbling. So, this video here is mysterious interstellar object is racing through our solar system. What is it? What is it? All right, so shout outs to Brightside. We're gonna check this video out. Here we go.
Sirens sound. People run in different directions in search of bunkers and underground shelters.
That's exactly how I feel, bro. I feel like sirens need to be sounded. We all need to get to our TVs. It needs to be something out there that alerts us, boom, and everybody gets to their TV to see what's going on in space that could possibly be about to affect us. Seriously, the perfect.
People run in different directions in search of bunkers and underground shelters. Dozens of planes take off to defend the Earth, all because our sensors have detected an extraterrestrial civilization ship in our solar system. Breathe a sigh of relief. It's only an asteroid, though shaped like a spacecraft. And it's the first interstellar object to be discovered in our solar system in history. It's called Oumuamua. This object came in here from the deep interstellar space. It has an elongated shape and is about half a mile long. Hey, it's bigger than Eiffel Tower. And it was moving toward the center of our solar system at about 31 miles per second and kept accelerating. At that speed, you could cross the Atlantic Ocean in less than 2 minutes. Our scientists speculated for a moment that it could have been a spaceship of extraterrestrial civilization and decided to check it out. Normally, spaceships and other human-made objects emit radio waves for communication. So, the scientists used breakthrough listen radio telescopes.
Wait, did y'all hear what he just said? Did anybody else catch that? I'm gonna back it up. Did y'all just listen to what he just said? Normally, this is what happened when this happens.
Check it out. Normally, spaceships and other human-made objects emit radio waves for communication. So,
I'm feeling like he just said that to get me stirred up, because he knew they knew I'd say. So what you're saying is there's been a lot of spaceships that we've came in contact with, if we've seen or gotten some type of communication from. That's what I feel like.
Spaceships and other human-made objects emit radio waves for communication. So, the scientists used breakthrough listen radio telescopes in Australia and the United States to try to receive a signal from the interstellar object. And nothing. Complete silence. Of course, many speculate that the radio silence is not a clear proof that this isn't a spaceship, but all the evidence points to it being an asteroid after all. Although it's been traveling in our solar system since about 1995, our scientists spotted it in 2017 after it flew at a critical distance from the Earth. So one astronomical unit is—
That's insane to know that it could have been in our solar system since 1995, bro. 95, how old were y'all? Where were y'all at in 95? What were you doing?
The distance from Earth to the Sun. Oumuamua approached Earth at a distance of 0.1 astronomical units. If Oumuamua had hit Earth, the consequences would have been catastrophic. The energy the asteroid had is its velocity squared multiplied by its mass. Since we know its speed, scientists needed to determine the second component. In here, they made another discovery. Our only option was to observe the asteroid from afar with telescopes, and we could figure out its weight not by putting it on a scale, but by understanding what kind of light it reflected. For example, iron reflects certain types of light waves, while coal reflects others. And that's where scientists realized that Oumuamua is constantly flashing. The light first slowly fades away and almost completely disappears. Then the asteroid starts to be bright again. It means that Oumuamua is spinning, but it doesn't do this like an arrow, rotating around its axis. The asteroid also spins horizontally. and its front and rear ends rise up and down. This chaotic motion made scientists think that Oumuamua was brought here by some incredible force from interstellar space. That kind of rotation would have torn the asteroid apart, but it's still intact, which means it's mostly made of solid rock and maybe even iron. So if Oumuamua had hit the ground, it would have created a crater the size of a city, and the blast wave would have destroyed everything around it for hundreds or thousands of miles. The sound of the incident would have been heard even on other continents. Fortunately,
does this not make y'all so grateful and thankful for the scientists and physicists and astronomers that we have on our front line? The way they were able to calculate and figure out what this thing was, and then, you know what I mean? How do we need to approach it and stop it?
Oumuamua flew past Earth and continued its acceleration toward the sun. At its closest point to our star, the asteroid reached its maximum speed, 54 miles per second. At that speed, you would travel around the Earth in just 7 minutes, but only the gravitational pull of the sun couldn't give this debris that speed. Normally, comets can accelerate even faster because of the rocket effect. The sun heats up the comet, and light elements there begin to evaporate. As they evaporate one way, they push the comet the other way, like a rocket. And it's because of these elements that we can see the comet's long, bright tail. But Oumuamua has no tail, so this speed was given to it originally, in the place where it was born. Some people speculate that Oumuamua used to have a tail. When it entered our solar system, there was a huge layer of nitrogen ice. Over the years, this ice melted and evaporated. This accelerated the asteroid and created a huge tail behind it. But then, the ice, which was 95% of the asteroid's total weight, ran out, and all that was left was this long, narrow wreckage that was discovered years later. Well, scientists can neither confirm nor deny this theory. So, Oumuamua approached the sun from about 0.25 astronomical units away. This is closer than the orbit of the first planet near the sun, Mercury. The asteroid then fell into the star's gravitational trap. It made a hook around it and flew out like a slingshot. It's now headed toward the constellation Pegasus. So scientists believe that Oumuamua was born from a dramatic collision of an exoplanet somewhere in another star system with another massive object. As a result of the explosion, a huge narrow fragment was ejected into outer space, and for this reason, it continues to spin madly. This dramatic event could also have been a supernova explosion. Such explosions occur when a star ages. It runs out of fuel inside itself and shrinks for a split second. And then, bam! A powerful bright explosion is visible for light years around.
And how many stars do we have in our universe? In our galaxy? Exactly. So what does that mean? How often my question is now, how often can this happen? Pretty often, right? I'm asking, that's what I'm asking, like, because now my mind is like, okay, we caught that one, we saw that one, now we got to be on guard for the next one at any moment in time. Again, why I'm thankful for the scientists, astronomers, and everybody on the front lines over there, because their heads got to stay on a swivel now. You know what I'm saying? Like, wow.
The blast wave from a supernova could rip some exoplanets into small pieces. One of them is Oumuamua. Or perhaps this asteroid came to us from the birth of a new star. First, there was a nebula. It was heavy and shrank around a common center of gravity. When the nebula's core became too compressed, it exploded, and the asteroids and cosmic debris burst into different directions. Scientists were considering sending a space probe to the surface of Oumuamua. We could study the interstellar body and use the asteroid as a taxi to other worlds. Flying to other stars with existing technology and rocket engines would take an incredible amount of time and fuel. But if we ride an asteroid, just like a horse, it could do the job for us. One option was to use a probe with a sail. Then instead of traditional rocket engine, the probe would be propelled by solar wind or a powerful laser. This concept would involve launching about 1,000 probes, each weighing less than a sewing needle, and each of them would be attached by cables with a light sail as big as a boxing ring. Then ground lasers will focus their beams on the sail and allow the armada of probes to accelerate to 20% of the speed of light. That's the speed needed to catch up with the asteroid as it leaves the solar system. Scientists thought we could use a gravitational maneuver around Jupiter to reach that speed in a conventional spacecraft. But we never made the launch, and it's too late to catch up with Oumuamua. Right now, it's heading toward the edge of our solar system and will soon leave it forever. Oumuamua was the first object to visit our solar system that we could observe and study, but there have been such guests here before. There's a theory that about 70,000 years ago, we were visited not by a meteorite, but by the double star system, Scholz's star. It approached the Oort cloud. This is such a wall of asteroids, space debris, and blocks of ice far at the edge of our solar system. The star's gravitational field began to trap this debris and throw it toward the sun. This may have been the reason for the frequent meteorite impacts on Earth's surface at that time. The star's gravitational field shook up the planet's orbits in the solar system a bit. If the star had continued toward the sun, it's likely that this world would have been gradually destroyed, planet by planet, and it would have ended with the sun colliding with this red dwarf, followed by a massive explosion. Fortunately, the rogue star only barely touched the border of our world and continued its journey in the other direction. But we're waiting for a new guest from interstellar space, the star Gliese 710. Right now, it's moving toward our solar system at 32,000 miles per hour. That's twice as fast as our rockets can go. As Gliese approaches the Oort cloud, it'll start throwing asteroids in our direction. Gas giants like Jupiter will intercept most meteorites, but every day about 170 meteorites of various sizes and shapes will fall to Earth. That is 10 times more than what is falling on our planet now. You already know all the following consequences. Boom. But the arrival of Gliese 710 won't happen for at least 1.2 million years. So exhale with relief and look at the first interstellar object made by humanity, the Voyager space probe. 2 of these probes were launched 44 years ago and are still operational. Voyager 1 was the first space probe in history to cross the heliosphere, the boundary of our world where the solar wind stops blowing. So this probe essentially carries the title Interstellar. Perhaps many years from now, Voyager 1 will enter another star system and say hello to a possible civilization like ours that lives there. To that end, both Voyagers are equipped with gold plates with a message for other civilizations. There's slides of Earth landscapes, recordings of human speech, our DNA, and many more things.
Yo. Shout outs to that's why I love the Voyagers, man. Oh, don't go to another video. But that's why I love the Voyagers, man. You know what I'm saying? Like, bro, I get hyped when I hear all the capabilities that they have and different things. Like he added on that little bit at the end. We're prepared and we have things on Voyager that way if we do run into a civilization. You know what I mean? And yeah, they're prepared. They're prepared for everything, bro. Hitching a ride on some asteroid. Like, it's just mind blowing to see the things there. It's like NASA's a bunch of kids in there and they're just coming up with different things and putting it into play. Whatever their mind can think of that we could possibly need to do to discover more or that could further our advancement, they're doing. And they love doing it. You know what I'm saying? So I would love to interview some of them, man. And one of the main questions, well, not the main question, but one of my questions I would always ask them is, does it feel like work? Doing this, what you love to do every single day, man, how does it feel, bro? And what are you looking to get out of it? You know what I mean? And then if we do find or y'all discover some life somewhere else, what is going to be your response? You know what I mean? Like, I got questions, bro. I got a lot of questions for them if I ever get a chance to interview, you know what I mean, one of them. I would love to do it, you know? But y'all get at me in the comment section. Let me know what you thought of this video, man, and stick around and stay tuned. Go.